Alright guys, so we're picking up with part 2 of the human body. And so the next thing that I want to talk about is the blood flow through the heart. So looking at the blood flow through the heart, I've listed the 14 steps, and everything that's listed in blue means that the blood there is deoxygenated or lacking oxygen. And everything in the red is going to be where it gets oxygenated, and then everything from that point. Okay, so this just kind of gives you a visualization, and you can see that that kind of corresponds to the picture listed here, where blood comes from both the superior and inferior vena cava. The superior brings the blood return from the upper body. Inferior vena cava brings blood return from the lower body. And those come together, and it passes into the right atrium. Right atrium will move through the tricuspid valve, right, down into the right ventricle. It's going to then be pushed up through the pulmonic valve and into the pulmonary artery. Now this is very unique because the pulmonary artery is the only artery in the whole body that carries deoxygenated blood. Generally, we think of arteries, we're thinking oxygen-rich, bright red blood there. But the pulmonary artery and the pulmonary vein actually flip the script on us. So pulmonary artery is carrying deoxygenated blood down to the lung. Okay? So it makes its way down to the lungs, and it receives oxygen. It makes that exchange that we were just talking about at the alveolar level. So the blood is in those capillaries there, and it's making that exchange inside of the lungs. It's picking up oxygen, and it's going to come right on back through the pulmonary vein. Remember I said that's a little different. It's going to come back to the pulmonary vein, and it's going to move into the left atrium. And then it's going to move through the bicuspid or the mitral valve. There's two names that you can use for that, bicuspid or mitral. I like bicuspid because it's easy to remember. Tricuspid, bicuspid, tri before you buy. Okay, so it moves through the bicuspid valve and down into the left ventricle. And then it's going to make its way through the aortic valve, down through the aorta, and spread out to the rest of the body. And that's pretty simple blood flow through the heart, 14 small steps that it's making there. And this is happening every single beat of your heart. So it's happening roughly 60 to 100 times per minute without you even having to think about it. And that's pretty amazing when you actually do stop and think about it. So blood flow through the heart, you might see that again. Now, looking at the heart itself and just a few facts here, like I said, the average resting heart rate for an adult is between 60 and 100 beats per minute. And we'll talk a little bit more about what generates that impulse once we get to the cardiac chapters. Now, much like we talked about minute volume, we're going to take a look here at cardiac output and what creates that. So stroke volume is the amount of blood that's moved by one beat through the heart. Okay, so everything that we just looked at, that's stroke volume, the amount of blood that's pushed through that in one beat. The cardiac output is the amount of blood that's moved in 1 minute. Now again, just like with the minute volume, is this something that we're really going to be measuring out in the field? Absolutely not. They would take a closer look at this number in a hospital setting. But in the field, what can we do to determine cardiac output? That's easy. We need to look at the pulse, rate, rhythm, and quality. As long as we've got that and that's good, then we know our cardiac output is good. When we start having issues with the rate, rhythm, and the quality of the pulse, then we know cardiac output is starting to decline. So heart rate times stroke volume is cardiac output, and same concept applies as it did for minute volume. If one of these numbers changes, the other one is going to change as well. The higher the heart rate, the less blood that's being pumped through in one beat. The lower the heart rate, the more blood that's trying to be pumped through as far as stroke volume. So just keep that in mind, not anything that you're really going to see or have to do in the field, but just that you understand what those terms mean and understanding how we can get a good, decent measurement of cardiac output in the field. Looking at the composition of blood, we have plasma, which is what makes up the majority here, and that's the liquid portion that contains water, proteins, oxygen, CO2, nitrogen, nutrients, and cellular waste. So very important that we have enough plasma to get these blood products where they need to go. Then we have red blood cells. Those are called erythrocytes, and they contain hemoglobin, which carries oxygen. And so we're going to get into that a little bit more in the respiratory chapter in talking about what does it mean, what can hemoglobin pick up. It's not just oxygen. Unfortunately, it can pick up waste products as well, or CO, CO2, chlorine gas, things that can displace oxygen. But we must have enough red blood cells, must have enough hemoglobin to completely oxygenate our body. The white blood cells, leukocytes, these help fight infection, And then platelets, these are essential to the formation of clots. Now, as with everything, it's better to have, you've got to kind of be at an exact homeostatic level. So too much or too little of any of these things could be a problem. Okay, you have too many white blood cells, that could mean some type of cancer. You have too little, you're not going to be able to fight off infections. Too many red blood cells could be a problem. Things start clumping together. Too little, you're going to be anemic. You're not going to be able to carry oxygen the way you need to. Too many platelets, and you're going to have too many blood clots. Not enough platelets, you're not going to be able to form a clot and stop bleeding if you're injured. So a very fine line that we walk in keeping that homeostatic level. Moving on to look at the central nervous system, that central nervous system is going to be broken down into a couple of parts. So that's the brain and the spinal cord. So the nervous system itself is the central nervous system and the peripheral nervous system. Well, we're looking right now at the central nervous system, the biggest component of that, which is the brain. Now, the brain is the controlling organ of the body, and it has a couple of subdivisions here. So you have the cerebrum, which makes up the largest portion of the brain, and is responsible for things like hearing, balance, and speech. It's usually the most easily injured because it contains so much of that. The cerebellum coordinates your body movements, and then the brainstem controls those functions necessary for life. So that's where we're going to get a change in heart rate, blood pressure, respiratory rate. All of those things going to be coming from the brainstem. Now, the second part to this central nervous system, not pictured here, is the spinal cord, which is just an extension of the brainstem, and is going to be protected by those vertebrae that we looked at in the very first slide of the Part 1 video. Now, the second part of the nervous system, the peripheral nervous system, is broken down into two parts, somatic and autonomic. So the somatic nervous system helps transmit signals from the brain to your voluntary muscles. These allow for walking, talking, writing. It allows you to sense things. So if something is too hot or too cold or painful for you to touch, your body would send out a signal to say, hey, this hurts, let's move. That's what the somatic nervous system does. The autonomic nervous system controls your involuntary actions. And so this is split into two areas, the sympathetic and the parasympathetic. And those two terms you're going to hear over and over again. So very important that you understand what they mean. We'll look a little bit more closely at that in the nervous system chapter, but just understanding that your sympathetic nervous system is going to gear you up to fight or run away. That's a natural instinct. So it's going to increase your heart rate, increase your respiratory rate, dilate your pupils to let light in. And it's going to reserve the nutrients and liquids that you have, so you're going to have less digestive process. The parasympathetic, your body's at rest, and this is how you normally are unless you're under some type of stress that's activated your sympathetic nervous system, and that's rest and digest. So your heart rate can be normal, respiratory rate normal, blood pressure normal, pupils are normal, slightly constricted, you don't need as much light let in, and you're always continuously digesting and creating urine and feces. That's where we're at most of the time, rest and digest. The integumentary system, or the skin, this is going to protect the body from a lot of outside things. You can see the levels here. You have the epidermis, which is that top layer, continuously shedding. We have the dermis lying underneath that. And then we have the subcutaneous tissue or fat that's going to be just above the muscle that's going to provide us some protection there. So we'll look a little bit more closely at this when we start talking about soft tissue injuries and how this protection can be breached. But these are just the portions of that system. And then lastly, we have the digestive system up here, and I pretty much just wanted to show you guys how this is divided up into 4 quadrants. So you can see those lines that are listed right down the middle, both going up and down and side to side. We think about those as imaginary lines when we're doing our patient assessment. And so when you think about those quadrants, you're thinking right upper, right lower, left upper, left lower. And so these are just the organs that lie in those corresponding categories. So if you're palpating in the patient's left upper quadrant, you would expect them to maybe, if they're having some pain, they're having an issue with their stomach, not necessarily their liver, even though it could be referred pain, which we'll talk about more in the abdominal section, moving over from another part. Generally, we're looking at the organs that are lying in those quadrants. Is there an issue with them? Okay, so that's going to wrap us up for part 2 of the human body. If you have any questions at all or don't understand anything that I talked about or that was in the initial PowerPoint, please feel free to email me. Thanks, guys.